And now we're given this circuit that contains a single source, and it happened to be just a dependent source. There are no independent sources in this circuit, and we're asked to compute the Thevenin equivalent. All right, so let's start by doing this. So first, we're gonna try to figure out what the V Thevenin is, or the V open circuit, okay? And that basically is what's the voltage between here and here, the V open circuit. Of course, we can simply just write nodal analysis in here. We can put the reference in here and figure out that. That will be our V open circuit. So that will be 2Ix plus V open circuit divided by 4 plus V open circuit divided by 2 equals 0. All right, but we need to figure out the Ix in terms of the V open circuit. Well, we know the Ix. Well, where's Ix? Ix is here. It's simply, and this one here between here and here is a VOC, and the circuit is actually going to the negative side, so that based on Ohm's law, that will be negative V open circuit divided by 2 ohms. Okay, so I'm going to just basically combine these two. That means it's 2 times V open circuit divided by 2. Actually, there's a negative in here because of the passive sign convention, plus V open circuit divided by 4, plus we can say V open circuit divided by 2 equals 0. And if you take a look at these, I have one equation, one unknown, and you will see that the V open circuit will be 0. So that V open circuit is 0, and as it turns out, it's accurate because there are no independent sources that are driving anything in this circuit. This is dependent because I only have a dependent source. That means this particular circuit needs an external independent source to run it. So the V open circuit is 0. And as it turns out, that in these cases, the Thevenin equivalent circuit is just simply a resistance. Okay, so let's find that value of that resistance. Well, first let's try, well, which method? Well, we have method, we can apply method 1. However, method 1 tells us you have to turn off all the independent sources. Well, I don't have independent sources, I have a dependent source, so I can't turn it off. So method 1, I can't use method 1. How about method 2? Well, technically you can't use it because you have to have either independent sources alone, or a mixture of independent, and I'll show you why now. So here's that. So the second method tells me that you can actually do this here. What the second method tells me, and that's method 2. Okay, so method 2 tells me that you can come in here, you do a short circuit, okay, and then what you have to do is you have to figure out what the I short circuit, and based on the value of I short circuit, you'll figure out what the R Thevenin is. Okay, so let's try to do that. Well, first of all, this is a wire that is in parallel with this resistance. So that resistance is shorted, this resistance is shorted, and you will basically write the I short circuit is simply negative 2Ix. Okay, because this Ix will be the only one going here, since no current going in here, no current is going in here. Alright, so I need to figure out what Ix here. Well, Ix is the current going through a resistor that has a voltage of 0 across it. So really, Ix is just simply 0. That means it tells me that the I short circuit is also 0. So, well, that's 0 because there are no sources to drive the circuit. And if we were to compute the R Thevenin based on method 2, you will see that it tells you that it's V open circuit divided by I short circuit, but this is 0 divided by 0, this is undefined. So we cannot use method 2, and that's the reason why. So that leaves us with method 3, and method 3 is the only one that we can actually use when the circuit does not have anything but dependent sources in here, so like the one in here. All right, so what does this tells me? Well, turn off all the independent sources. They're already turned off, they don't exist. Then connect the source in here, and that source could be a voltage source or a current source, it's up to you. We can figure out that here is a VT, and I can set it to be 1 volts, for example, and my task now is to figure out what the I of t is in here. And if I figure out what the I of t is in here, I can just divide them by each other, and I'll figure out the value of that resistance. Alright, so let's do this here, and I believe nodal analysis will be the simplest. We can just write in here because I know that voltage in here. Actually, I don't need nodal analysis because I know that that is VT, it's 1 volt. So I pretty much know all the voltages and currents in the circuit. So let's figure out, what am I looking for? I'm looking for I of t. I of t, I'm going to write KCL in here. So let me just name the currents. So for example, I can do this here, I'll call it I4. Okay, and this is Ix, and I have 2Ix. Okay, so we will have 2Ix is leaving, I4 is leaving, and then Ix is going in, and I of t is going in. Okay, so let me just say 2Ix plus I4 will be equal to I of x plus I of t. Okay. Again, what I did is I said, well, I4 is leaving, 2IX are leaving, so both of them will be on one side. And then I said, well, IX is coming in and IT is coming in, so they'll be on the other side. All right. Well, let's double check. Do we know the value of I4? Because let's double check what the value of I4 and IX is. Well, I know the voltage across them, so let me just write this. IX is simply, well, I know the voltage in here, that's negative, that's positive, that's VT. It's the same 1 volt, okay? And since this current is going to the negative first, so IX is just simply negative, okay, 1 divided by 2, okay? And that's in amps. How about the I4? Well, I4 now, this is also plus minus VT in here. It's the same thing, but this time the current is actually going to the positive, so it's positive sign. So it's positive 1 divided by 4 amps. Okay, so let me just combine all of these. 2IX, which is 2 times negative 0.5, plus I4, which is 0.25, equals IX, which is negative 0.5, plus IT. And now it's one equation, one unknown. Let me figure out what the value of IT is. And that happened to be negative 0.25 amps. Alright, so I know my I of t, I know my V of t. So based on method 3, it tells me that R Thevenin is just simply V test divided by I test. And I know my V test happened to be 1 volt. And this is negative 0.25 amps. That means this one here is negative 4 ohms. Okay, so the R Thevenin happened to be a negative 4 ohms. You might be wondering, well, we made a mistake in here. How can we get negative 4 ohms as a resistance? Well, it's a little bit strange, but this is only because it's Thevenin equivalent. Resistance, as you know, should be positive. This is the only case where it can be negative. And the reason why it's negative is just an indication that this is an equivalent circuit. And if you connect an external source, that tells me that this particular circuit is actually generating power. So it's not a resistance, it's an equivalent to a circuit that is generating power. So if you're actually connecting this source in here, the rest of the circuit, whatever it is in here, will be generating power. And you can compute that, and that's why it has that negative part in here. So this is not a negative resistance, it's just so that when you compute power, you'll get that this particular part of the circuit, or this circuit that we figured out the Thevenin equivalent for, is generating power.